Hey everyone, welcome to our Kotlin Multiplatform Mobile webinar. It's the first KMM webinar on our YouTube channel, so I'm totally excited. My name is Kate, and I'm a developer advocate for Kotlin Multiplatform Mobile. You can find a couple of my KMM tutorial videos. Subscribe to our channel so you don't forget to check all the useful KMM and not only content later after our session. But today, we will not go through the steps of creating the next KMM application. No, today we have another exciting format. This webinar is dedicated to the most frequently asked questions about the technology, about its usage. And of course, I think the best source of knowledge for such questions is someone with lots of hands-on production experience. So today, I'm going to interview Kevin Galligan from Touchlab. Kevin is a partner at Touchlab, and he has 20 years of professional software development experience and has been working on Android since the first public platform release. Amazing. Kevin is currently focused on developing and evangelizing Kotlin Multiplatform native tools for the next generation of mobile development. Well, I'm sure you already know Kevin for his great contribution to the community. And let's say hi to Kevin. Hi, Kevin.
Hi, how are you doing?
Thanks, and you?
Pretty good, pretty good.
Okay, so today, together with Kevin, we will walk through everything you want to know about KMM. Here, we have 7 questions which are often asked and could be considered, quite complex. So you won't find like one sentence answer for them in the KMM documentation. These questions, they imply, good discussion. And that's exactly what we are going to do today. And I think the most attentive of you may notice that 3 questions are missing. We promised you 10 questions in the title of our webinar, but please don't worry. This is a place for your questions. So please don't hesitate and write your questions in the chat, in the YouTube chat. We will choose the best ones and we'll answer them in the end of our session. And well, I think let's go. Let's dive deep and let's start from some general ones and then go deeper to some specific ones. Today, mostly about iOS, but well, it's quite expectable. So let's start with quite common. So Kevin, which parts of your project do you prefer to share and why?
So I think the important thing to start here is defining, you, right? So me personally, and when we build small sample apps or if we're doing something brand new, we tend to try to share everything from the UI down. So the UI, once your data and your other things get to the UI layer, we try to keep the UI layer kind of, I won't say as dumb as possible, but as uninvolved in the logic as we can. And you can get a lot of shared code that way. In larger teams, it's kind of a different thing. And we spend a fair bit of time working with larger teams. So they tend to focus, this is generalizing, but they tend to focus more on specific modules that are perhaps complex, perhaps things that people don't necessarily want to do. Like again, talking about databases is a good way to start, or analytics, things like that. It tends to be more module focused, and larger apps with larger teams. I don't know if you've ever seen any of these production environments, but they might have tens or more of separate modules that are all kind of wired together at the end of the day. But they tend not to get as involved in sharing threading and architecture. That the more complex the app, they tend not to do that as much, but some do. So it kind of depends. But yeah, we have a few projects that have been KMM greenfield, starting with like a small-ish team, and we'll work from essentially, we have a coroutines enabled layer that exposes flows and suspend functions to Android, let Android manage lifecycle directly because it's They've obviously been putting a ton of work into that. And then we sort of have an iOS lifecycle simulation layer, and then that exposes methods and callbacks to the iOS layer, and essentially the UI is just doing the UI, and it's not doing any logic. So that's what we attempt to do. But there's practical realities that sneak in there too.
Mm-hmm. And when you speak large teams, the main reason is large code base or a big team, or it's both. Why it's important for them maybe to not go directly to the whole layers in the KMM?
So I would say that I have a condensed slide, which we probably should have shared with you. Then you could have shown it. It's the reasons why Kotlin is a great option versus the other options that are out there. And one of them is a low risk incremental introduction possibility. So you don't have to do everything at once, and you can introduce critical, difficult things into a team. You're going to have team members that are skeptical. You're also going to have team members that don't want to disrupt their current builds. There are nightmares out there when teams tried to introduce Swift into an Objective-C ecosystem when Swift is new, and everyone remembers that. So you kind of have to prove it'll work. You have to do it in a low risk way. So it's more of a practical. They'll start that way, and then if you have dedicated iOS developers and a dedicated iOS architecture, I do think there comes a point with diminishing returns of trying to also do all the multi-threading and the logic and everything all the way up to the top if you have an existing project. So that becomes the debate, and that will, I think, it'll change over time, especially if you get a team bought into it. And as we'll probably get into it later in this discussion, when multi-threading changes, libraries mature, compiler plugins mature, IDE integrations are always improving. So it's a process of time of selling a team on it, and then I think the ecosystem matures, and you'll see different teams do different things. Some will never get beyond certain modules. Some will probably start adding slices of functionality that are more complete shared Kotlin, and then do things differently. Even some apps, if you have a large enough team, you'll have one app with two teams that really don't even work together. I'm not talking Android and iOS. I'm talking one app where different iOS features are implemented by entirely separate teams.
Product feature teams, yes.
Yes, exactly. Right. Thank you for the proper industry term. Yes, but exactly that. And you'll have some teams that are, I can't say which client now, but we have one client with, we're starting with multiple teams coming up this coming Monday, and they do things entirely different, but it's the same client. So you'll see, and it's once the team sees the value and feels comfortable with the build process and the libraries and the ecosystem, it becomes more of a thing that you can push for. But it has to be a value proposition, and it has to not risk the existing situation, right? So.
Right, I agree. This flexibility is the main beauty of KMM and Kotlin multi-platform stuff for me. And based on that, let's imagine the case with a large team and the new project. Maybe let's imagine this amazing world where they have they have time for maybe experiments, and they even can risk. For that situation, what would you recommend? What approach, maybe, or what process?
For a brand new app, and they're already sold. Well, I would say one of the things that's difficult, is politically difficult with the team, is that as much as we try to dance around the obvious issue is that it's a very Android-centric approach, and only because Kotlin is the default language in Android. I would imagine often, the team that's pushing this is probably more of the JVM side of the world / Android side of the world. So there's getting past, I would say, occasionally political issues, but this one, if you're going to start a new app from scratch, we tend to do it this way too. You're kind of leading with your Android development. You're going to delineate what's going to be shared, and let's take the concrete case of what we're working on now. Like we have essentially view-oriented logic transform as the last stage, and then database access and another thing, like stuff like layers that are going on there. We plan that ahead, and we code with that. But essentially, you kind of you have to have people that understand KMM. Like it's not realistic to think that even an Android developer is just going to say, okay, I'm going to do shared code now. Because there's an understanding of just mechanically how iOS works and compiles and understanding the memory model. So you do have to have a core team that kind of understands how that's going to work. And you start from there implementing features and then doing the UI in Android. And then as that settles, you can add those things probably in the following. Like we tend to try to do like one sprint, you're doing the Android thing, and then the next sprint you're have a ticket to implement the iOS UI. And it's mostly works. Sometimes it doesn't go as smooth as you'd like, but especially, we're a special case, right? Like Touchlab, because I've talked about the memory model a bit, so everyone on their team understands it enough,
really,
to get through their day, right?
Yeah.
If you're starting brand new, it is important that you have some people that are going to have to understand enough about both platforms and the unique features of KMM to code those things out. But generally, it is a faster cycle to start to get through your architectural modeling with an Android top looking at it, and then adding iOS on top of it, which again, we can be politically feel a little bit like the stepchild platform, but it's not, but I will say it's also difficult to code the KMM part in a vacuum without having a front end pointing at it. So you generally end up coding it with Android, calling into it, and then adding the iOS on top. So I guess, but we encourage, especially with teams, to not make it feel like you're taking responsibility or capability away from the iOS developers. It's important to have them also be able to contribute Kotlin and be able to push code the other way, right? So if it feels like it's an Android first approach, it doesn't necessarily attract the iOS side to be excited about it. So you have to be careful with that.
Thank you. The next question, it's quite similar to the first one, but it's about numbers. So what % of code should we aim to share? I think we could separate this question depending on the case, as you mentioned, a small team or a large organization, existing app, new application. But I don't know, can you share some numbers?
No, I don't have numbers. I'll tell you why. I feel like I understand where the question's coming from, but I don't think it's the question to ask. So if you're looking at this purely from trying to have a quantitative, I need to talk to the upper management with something, and some convincing thing to I understand why that stat would be useful. And I've seen people argue that. I've been doing shared code, quote unquote. I was trying to do something with J2BJC long before KMM. So I've been in this, let's say the world of trying to sell people on something for several years now. And I've seen a lot of this where it's here's the X% of code we've shared. Here's the X% of code that you could possibly share. But I don't know. To me, it sounds a lot like measuring productivity in lines of code, which is known to be not necessarily a good way to measure. And especially in this context, if you have a large team and you're sharing certain modules, the question is immaterial to begin with, because you're not trying to maximize lines of code shared. But especially in what we're doing, if you actually looked at the lines, even with a greenfield app where we're trying to share as much as possible, the UI has a lot of code. I mean, there's configuration files, there's style files, there's lines of code that are, you're setting up your UI and wiring up. There's boilerplate, God forbid.
If we count zip files for iOS development, we could be very productive modifying our UI. Yes.
Right. But not that UI is less important, but if you don't have the right radius on a button, that's a different thing than if you have an incorrect calculation in your tax calculation module. So I look at it like this core architectural stuff, the really hard calculations, the things you have to get absolutely correct. Each line of code, it's not even so much that the line of code is worth more, it's that an error in that line of code is far more damaging. So like that particular line of code is probably a lot more valuable than the one that sets up the radius of the border of the button. Because if you get it wrong, people aren't going to get that upset. So that's kind of the way I look at it. I try not to maximize it so much as duplicate code, especially logic code that has nothing to do with a particular platform. It's just adding more time to code and test and certainly update and maintain over time. And it's just adding more places where you can have bugs because you didn't properly change both sets of code in lockstep. So I don't measure percentage, but there you go. Also, if your app is mostly UI, how much code are you going to share? You probably shouldn't even try, right? Whereas if your app is doing like really, really complicated calculations and the UI is like just a text field and a couple of buttons, you're going to share almost all of it. But so it all depends on what you're building.
Well, maybe we should introduce some factors, some ratio to our modules, like UI is not important and networking is more important, and then count the sum.
if you say that UI isn't important, that upsets people, rightly so. It's not that it's not important. It's just that if something isn't laid out exactly correct, it is not going to cost your business an enormous amount of money. It'll just get, maybe a 4-star review instead of a 5-star. You know what I'm saying? Like, so, but UI is very important.
You mentioned this discussion with management. Then, if not numbers, what should we use to pitch KMM, to introduce it? It wasn't prepared, but well, it's a discussion. So
no,
sorry, Kevin.
I mean, not those numbers, but I give a more of a logical argument, right? Like, the history of computing is it's a progression of an attempted to reduce redundant work, and at the same time we're like recoding the same exact logic multiple times. So if there weren't any build barriers or tooling barriers or political barriers to not recode the same logic, you would be crazy not to do it. The reason that we don't do it is because there are a number of imperfect compromises that you have to make. So if you were going to use C++, and there's an infamous, famous blog post from Dropbox, if you're in our little shared code world, that's interesting, that says sharing code basically sucks. But it's a really good article about why sharing C++ code is not great. But it's not like, it doesn't really, most of the problems are related to that particular ecosystem. And then it was interesting, I was at a DroidCon San Francisco talk with that author, and they talked all these reasons why this wasn't good for them. And then at the end, he started talking about why they're using Rust to share code. And I was like, dude, you're like completely, like your point is completely logically blown. Like what you're saying with Rust is, in this case, Rust is a great ecosystem for this particular problem. Like, okay, so that makes sense to me. So people often write it off, but like, if you didn't have any issues, it would be crazy not to try to share code. And the reason why we like Kotlin as a shared code option is the team has done enormous amounts of work to solve the really hard problem, which is getting rid of the compromise barriers, the interface, the interop between the native code and the shared code is, it's very good. I mean, there's one thing I tell people, like, it's never going to be perfect. Kotlin is not Swift. Even if you get Swift interop, Like it's not Swift. So you have to be prepared for some compromise. But the compromise in this situation relative to other situations is a whole different equation. Like it's much less compromise, and a lot of the big problems are at least reasonably solved, if not like removed. And then you have to decide for yourself if it's worth it. So anybody logically would say like one set of code is better than two. They just don't do one set of code because the barriers to having one set are more trouble than they're worth. And the pitch with KMM is that the barriers aren't more trouble than they're worth, right? So
yeah, I think this point about this relative thing is an important one. So let's imagine that we agreed on which parts we want to share, how much do we want to share, and you've already talked a lot about who should contribute to the KMM part, that it's Android specific, but well, iOS folks, they also should be involved. So who should own the KMM common code, in your opinion, in your experience?
Again, this kind of goes into how big's your team, how are you structuring your code? If it's a single, I'm thinking of a couple of examples of apps that we started from scratch, and we essentially just keep everything in a mono repo, and it can barely be called a mono repo, because when we say mono repo, they usually mean like a huge code base that's in one repo. We're talking about shared module, Android module, iOS module. And specifically in these cases, the team is too small for anybody on the team to not understand at least how to like modify Kotlin code. Maybe not set up a full architecture, but they can go in there and add a field to the database or whatever. In that case, I wouldn't say that anybody owns it. It's more like whoever's most senior does the PRs. I guess whoever is, well, not most senior, but like, you know what I'm saying? It's like who owns a small repo with a small team? It's the person who does the PRs, I guess. In a larger ecosystem, it tends to be a module or a set of modules are in a shared thing, then that get published as a library. In that case, you are going to have, a team that is, or it could be an individual, but a couple of people. It is going to, it's more likely going to be coming from the Android side. That's learned enough about iOS to function.
That was my next question.
But
this team of whom it contains, yes.
I think people minimize the accumulated knowledge of an iOS developer and how to function in an iOS build environment. Because the benefit and the difficulty of KMM is that once you're past the actual source code, you're into LLVM, you're into linking, you're into Xcode world. And just understanding when something is wrong, how to deal with that, I would say the accumulated knowledge of how to deal with that is more than learning how to code Kotlin if you're a Swift developer already. So we found that iOS-focused developers, I try not to say iOS developers, iOS-focused people, because developers are developers.
I like how it sounds.
Yes. If they're open to new stuff. Some people are just like, I'm Swift, that's it, goodbye. But like, if they're open to Kotlin and trying these new things, it's not necessarily more difficult for an iOS-focused developer to learn how to code Kotlin than it is for an Android-focused developer to learn how to build and exist in an Xcode world. You know what I mean? Well, it's not an Xcode, but like an Apple toolchain, Darwin toolchain world, right? Yeah. Most Android developers, like, they'll see LD : and a whole bunch of gobbledygook, and like I've been looking at that for a few years now. I could be like, yeah, you didn't put a linker flag for SQLite. That's what's wrong. But if you're an Android developer, you have no idea what's going on there. So generally starts with Android-focused devs, iOS-focused devs who like new stuff. I feel like can pick it up relatively quickly. The concurrency model is difficult for everybody, but that's a different discussion.
We're together here, yes. Well, for those iOS-focused developers who love new stuff, for them, what's the best way to develop an expertise in KMM? Because, you know, there are several approaches. You could start from learning Kotlin, idiomatic Kotlin, maybe, or deep dive into Gradle and spend a few nights watching Gradle tutorials. No? Okay.
Nothing wrong with Gradle, but no, I wouldn't start there. I think, you know, there's a lot of talk out there about how Kotlin is very similar to Swift. I've spent time like in the Kotlin compiler layer and like dealing with the fact that Swift and Kotlin actually have a bunch of different things like in how things are implemented. But visually, it's true, they are similar. But I would say you need to, it's kind of like how you approach any new language. I think unless you just started as a developer, you go through that phase where there's some cool new language and you just want to go learn it. So, you know, in the past, I've done, like, I'll just get a book and like read it casually, but you know, you don't really learn that way, but still, you kind of learn the basics of the language itself. I think you have to go do that. Go get the Kotlin cones or the work sessions online. There's a lot of good documentation, especially, I mean, your team's done amazing work over the last few years to make this accessible to anybody as a first language. Although I don't know how that's, I don't know anybody that's first in Kotlin. I'd be curious to see how that went. But it certainly couldn't be more confusing than JavaScript, let's put it that way, as a first language. But yeah, I think you go through and learn the basics of the language. And then I like to clone or get a sample that exists and then try to do something interesting with it. So do that first. I would say approach Gradle config later. And I say later. That as I just spent the last few days wrestling with Carthage. Any foreign config system that you aren't experienced with, especially, I don't know, not that Gradle's more confusing than anything else, but Gradle, especially now that you have Kotlin script and Groovy and the samples are all over the place, and it can be a lot. And I think learning the build system of any environment can be kind of a turnoff. Like I'm sure people love Carthage right now. I absolutely despise Carthage. You know what I mean? Like, just because I don't, it's like too much. So not Gradle first. Gradle when you need to do something different. I would say that. But I would take an existing project or something from the IDE's templates and do something fun. And then the next layer is like, all right, pick something you actually need to try to solve, like something that's not like, because if you go through a tutorial and read and it says, okay, add this, you're just going to copy paste. You're not really learning. It's like you need to have something where immutability exception, or you try to do something that like is going to be a real problem and you have to solve it. So that's how I do it. But or like when we have a new person start the team, like we try to cram in a few basics, and then it's like here's a ticket, and then we'll screen share and talk you through it. Like that's kind of how you learn, you know.
Samples is most favorite option among KMM developers, multi-platform developers to learn new stuff, to play with. I agree with you. It's cool that you, at the same time, you can just go through the repo, just read the code, and at the same time you can modify it and see how it affects. And about you mentioned Gradle later when you need something to do with it. I want to talk a little bit more about it. What do you think? Is it possible situation, for example, when iOS developer who is working on the KMM, on the shared module, then they know nothing about Gradle. They can write pure Kotlin, but they know nothing about Gradle, work with it like with a black box, and when something is needed, they just ask the Android-focused developers, Gradle-focused developers for help. What do you think? Is it a possible situation?
I would say, yeah, in most cases, it's not just possible. I mean, it's probably what's going to wind up happening. So we talked to another org, not a client yet, but they're all potential clients. But no, they're not. But we do a lot of, and if anybody's watching and interested, like reach out to the team. We do like, we'll just talk to you for an hour about what's going on, not in a client relationship. We do that a lot. So we talked to one, and one of the big issues they had was kind of that, like the project that they were playing with was MVP, and it got set up by an Android developer who's probably used to doing Gradle, although they're not used to the Kotlin KMP Gradle. So it is different. I mean, there's a lot you have to learn, but well, not a lot. I don't want it to sound daunting, but there's a fair bit you have to. But then they, one of the big complaints was that, well, then the iOS dev went in and tried to like change a bunch of stuff and add things. And I was like, did you spend a lot of time learning Gradle? And they're like, well, no, I was just trying to hack it. And I'm like, yeah, I mean, that's difficult. So I would say Gradle's a big surface area to learn things. So it's not like an Android developer will come in and just kind of magically solve everything. I mean, when I go in to do Gradle, I have to hack it too. I just happen to know a lot more about how Gradle works. So I don't know. I think it is, you're going to have to, it is kind of like anything else. Like it took me a fair bit of time to really understand how to configure iOS and how to configure, a standard iOS build. And then God forbid you need to do things in the command line and CI. Like it's just a progressive introduction of more complexity. And I think unfortunately more esoteric information. So my Carthage example, like if you're going to have one repo per module in an open source situation, Carthage is very easy. If you want to include a KMM binary library inside of a single repo where you also have UI code, which is a separate iOS framework, it is not easy. And you'll also, not surprisingly, find basically zero people who had to do that. So like, kind of the same situation here. Like, it's much better now, but if a couple of years ago you had to go look up how to configure a static framework in Kotlin using CocoaPods, like you would find basically zero people who had to do that. It's like you have to understand not only how to figure out how to do it, like you have to understand frameworks to some degree on the iOS side. Like there's a lot you have to learn. So it's an incremental process of increasing complexity, I would say. So I don't know, but it would be good, I guess, to learn basics of Gradle. I guess I've been doing Gradle so long, I don't remember how I learned Gradle. So I don't know, read a doc and then you see some examples and then it doesn't work. And then
try something, doesn't work, Google
and then you go to Google
again,
yeah.
and again and again.
Or you go to the Slack group and then you ask them. Anyway.
Okay, so
somebody just reached out. Step-by-step conversion example for Kotlin Gradle. It was Stacy, Hi, Stacy. Anyway.
Next one again is about iOS development, but well, it's quite expectable because, as you mentioned in the beginning, KMM is more Android-centered, Android-specific, and well, Android part is usually pretty straightforward. So today, the best questions and the most discussable ones are about iOS integration. So how do you package Kotlin iOS code? How do you share iOS frameworks? Again, you've mentioned kind of some approaches, but let's systemize them all.
Okay, Carthage, throw it right out in the garbage. No, I'm just.
sounds like a song.
Yeah, we're getting close there. It's so I would say for obviously the unit of code that KMM is going to output is an iOS framework, an Xcode framework, I guess is probably more formally. Even then, it's kind of do you make it dynamic or static? There's a few things to figure out. We tend to lean towards static. I know, even though dynamic sounds like it would be better just by the terms, but I don't know. Actually, you could probably explain that better than I could. What is the industry doing? Versus static versus dynamic. But I feel like it was static and then it went to dynamic for a little while. And now it's like static. But anyway, we for the smaller apps, the greenfield single team mono repo things, we just use it's actually the JetBrains CocoaPod plugin. The plus side of that is it's generally easy to configure. We had a fork for a while that allowed us to directly configure the framework Gradle thing, so you could like set some fields. Like there was no easy way to set a framework to be static. Like everything was dynamic. We just wanted static, and we also had an issue with debugging, which is no longer a problem. We reverted back to the JetBrains official, because maintaining a fork of something is work, and there's no reason to anymore. So you have to have the JVM installed. You have to be able to build locally, but otherwise it's relatively straightforward. And the round trip of making a change and then hitting play in Xcode or the KMM plugin if you're using it is fairly well integrated. I mean, the build time is longer on the iOS, although it's improved.
And it's a great time to mention that with the latest version of KMM plugin, wizards can create this structure with CocoaPods for you, because previously it was only with this regular framework option with separated Gradle task, but now you can generate the needed Gradle build file for CocoaPods integration also. Yeah,
and it's partially because of who we work with often. We tend to be, I don't know if it's just a random sample, we tend to be working with teams that are more CocoaPods focused. So I found that to be a reasonably straightforward way to configure projects, even though like Apple clearly doesn't care about breaking the CocoaPods world when they change Xcode definitions, which is like fine. Well, not that they don't care, but it's not top of mind. So anytime there's there is a long-term concern about whether or not CocoaPods is maintained, right? Because you have to, and I would say Carthage is running into that now with the advent of Swift Package Manager. Right? So, but that's a much longer discussion. We do for local stuff. We use the CocoaPods plugin. I don't think we do much in the way of just direct framework ingestion. Then Pack for Xcode, like we don't really do that. Then we also, with larger teams, more specifically around CocoaPods, but also Carthage compatible, we have sort of a not yet open sourced thing that will build a framework zip file, and you can configure which modules you want, and then publish that like a pre-built binary, and then you can consume that CocoaPod. Carthage actually works as long as you have one repo for that. If you try to have two modules in one repo, it's a nightmare. That's all. For me, because I don't understand Carthage. See? But
unexpectedly, a lot of mentions of Carthage.
I know. Well, no, the last few days was just like, this should be easy. I'll just bang this out. And then 3 days later, I'm like, I can't believe how not easy this was. But anyway, no. So we're for our larger team clients, we have we're working on a thing. I don't know if we're going to open source it or not. We'll see how mature it gets. But it publishes zip files and uses CocoaPods to do private pod specs. And then the benefit of that is, if you want to add that to your iOS build, it is just another CocoaPods binary that works. The downside of that, of course, is that if you're consuming packaged SDKs, you're not really getting into coding Kotlin itself. If you have a bug of some type, you can't fix it yourself. The
round trip is much bigger.
And it's not specific to Kotlin. Like this is a long-term problem. And what you get is orgs wanting to do it that way because it's easier mechanically, but it doesn't foster the idea that you're not an Android iOS developer, you're a mobile developer, which we encourage strongly because it allows, it's just better for development. So what we do is we have a little flag that it's an environment variable now, but if you want to just do local development, you flip that and then make sure you have the right repo and you point it out the right way, and then you you can quickly go from binary to local development. I think that that's pretty important. Otherwise, you get this long round trip cycle. But some teams, most large orgs, it's like, yeah, we get what you want to do, and in a perfect world we do it that way. But you have an internal SDK publishing team and then internal SDK consumers. So that's how we do. We haven't done anything with Swift Package Manager yet. I forget the name, but there is a Gradle plugin that exists for Kotlin to do that. I was experimenting with last night because you could also get XC frameworks, which some documentation
in the people in space sample, you can find an example of usage of this plugin. Yep.
John O'Reilly.
As usual. Hi, John. Thanks for all.
Hi, John. Thanks for all the samples. No, he's great. We 2019 DroidCon, I unofficially made it the KMP summit, and we had all the people you'd recognize. John came out for that. It was interesting. But anyway, so yes, you can use Swift Package Manager. I was experimenting with XC framework last night because Carthage doesn't like that frameworks or whatever. It didn't work out though. Carthage is still giving me trouble. But that's how we would package stuff. But like I would say as you get into larger teams and orgs, like any internal build system tends to get more and more customized. So it's kind of hard to generalize after a certain point. So.
Thanks. Again, it's a good time for mention for some release notes because we are talking about KMM and iOS integration. With the latest Kotlin release, there is Kotlin Multiplatform Mobile plugin now provides not for pack for Xcode task, it's the new task, but it serves the same purpose to allow you to integrate Xcode and your shared path, and you can do it now. You can now remove this pack for Xcode task and make your build Gradle files simpler and add some magic to this.
Finally, we get away from the copy paste method of software modularity.
Yes. Finally.
Yeah. No judgments. It was great.
Okay. Okay. So next one. Again, dedicated to iOS development, but we talk a lot about it today. But well, it's really the hottest questions. So, how does KMM impact binary size?
That is a great question, and we get that.
Oh yeah.
A lot. I had planned on finishing a blog post before this event. I did not. I've been threatening this blog post for at least a year, and every time someone asks this question in the Kotlin Slack, I write roughly half the blog post explaining this. But I will say the following.
Well, now it's a public promise, so
I know.
We're waiting for it.
You'd be surprised how much I ignore public promises like that, but. Only the ones that matter. Blog post is okay. So the first thing I think that comes to mind, you have to set the stage, and a lot of times it is, again, an Android developer that is pitching KMM, and they'll get this question, and usually the freak out moment is, I ran this and I looked at it, and it's 30 megs. And the first thing you have to say is, like, that's not how you measure an iOS. So like on Android, if you look at, the actual APK, that's what it's going to be when you download it on your phone. It's a little different now. Like, they do shave some things out of there, but iOS world is very different. Like, once you upload a binary, there's Apple servers somewhere that are magically chopping all the stuff you don't need and making specific binary packages for specific devices. Because not every device needs all the resources, not every device needs all of the architecture. And it's a good practice anyway, and Google's been doing more of that. But it's been more necessary in iOS, because the reality is, like, binary sizes in iOS are crazy. Like, at least relative to Android. Sorry to be judgmental about the iOS world. But like, look at Uber on iPhone versus Android. It's a crazy, and like, I'm sure there were points where Uber, like, you needed to get on Wi-Fi to download it. And usually you need Uber when you're standing on a corner somewhere and you need a car. So where's the Wi-Fi? I don't know. So you have to measure it properly. We used to upload the binary in a sample project to App Store Connect. There's ways you can do it locally too, but it's significantly more involved than just looking at the thing like this. So step one is measuring it properly. What we did then was we created a sample project that was just Swift with no logic in it, and then measured that against adding a really basic Kotlin logic piece of a function, right? We just added a function, no libraries, no nothing. And you kind of pay an overhead of runtime and just whatever. So that works out to about 500K on disk, 150K over the wire, which is the compressed size. And then it's sort of like the tax you have to pay. The next question is, great, like, how about the growth in binary sizes you're adding logic? So we did a test where we generated very simple, not production equivalent classes, but we just generated a whole bunch of classes. We measured at 50 classes, like 100, 200, 500. What happens to your binary size over time? And we did that logically equivalent Swift and Kotlin classes just to get a sense. I will say, in general, the binary size growth is equivalent and linear, at least in that arbitrary test. So after like 500 classes, it added something like 2 meg to both, right? So that makes Kotlin look very good as far as like something you can integrate. The negative part, when we got a bunch of freakouts from people, not a bunch, but a few reached out and were like, hey, I added a bunch of SQLite, added 100 tables, and all of a sudden, it adds 10 meg.
Dependencies. Yes.
Well, it's not that. So there's a secret thing that we kind of figured out. It's not really secret, but it is, if you have a lot of small classes, especially, if they're public, that generates an Objective-C adapter or interface. Mm-hmm. Interface is kind of a loaded word, so we'll say adapter, right? And Objective-C is a dynamic language in the same way that like Java is a dynamic language. Swift is not. Very static compile, as is Kotlin native. So in order to interop with Objective-C, you need this adapter. And I'll share the charts in the thing, but like if all of those 500 classes are public, it's way more than 2 megs. Something like, it's like 5 or 7 or something like that. And if you make all those classes internal, it goes back to just being equivalent. So there are actionable best practices, which are try to make everything you can internal. And then there's some things we've experimented with, like
it's useful not only for binary size, let's be honest. Well,
I know.
Just a good practice.
But there's a lot of moving parts there, we're experimenting stuff. But you can make it equivalent-ish, but you have to be aware of these things. But what I generally tell people is they're usually adding a module or a couple modules, and they're going to have the usual suspects for dependencies, like SQLite, KTOR, serialization, and I'm like, yada yada. It's like 1 to 2 megs. That's like the answer for everybody, unless you're doing something significant. So it's going to be a couple of megs. And in the iOS world, I haven't talked to a lot of people once they understood that, especially that public visibility problem. There aren't many teams that I've heard of that have not implemented it because of the size.
Yeah, I had such experience. So first, thanks for numbers. Second, we're waiting for the blog post. And third, I totally agree.
I was going to say, if you were bored now, wait for the blog post. You're going to be bored. You're going to go to sleep. Yeah. But yeah.
I totally agree about this point, this 0 point about measure properly, because I've also got a couple of questions about, oh my God, the binary is big, but it turned out that they're measuring fat binary that was built in the development mode, and all the stuff about you mentioned about how Bitcode is working for reducing binary size for final applications. So yes, this is really important, and that's why again we need your blog post. I will send it later for when I receive all these questions.
So again. I would say the best way to get the blog post is public shame. So just keep people tweeting at me for that blog post.
Okay, so the last one from the prepared list, and then we will go to the community questions, and we already have some really interesting ones. So if Swift interop is introduced, what does it fix? Do we need it at all, or we can just work with maybe Objective-C interop and, well, everything is working? What's your opinion here?
It's an interesting question. So immediately talking about binary size, I suspect if you don't need that Objective-C adapter, that direct Swift interop would get rid of the public interface problem to some degree. So the binary size would probably be less dependent on that. However, I feel like this goes back to another blog post eventually that I made, right? That is called, like, it's never going to be perfect. And there was a lot of pushback on the fact that it's an Objective-C interface from, let's say, the iOS-focused developer ecosystem. But the reasons why people like Swift are not, it's not just a prettier language. Like, there are structures in there, like structs, there's associated values. Like, those things are not going to exist, even if you have direct Swift interop to Kotlin, because they don't yet exist in Kotlin. There are equivalents, right? Like data classes feel like structs, right? Sealed classes? Oh man, I was about to fail my Kotlin test. Sealed classes feel like with associated values, at least logically, but you're not going to have those things, right? I will say, one of the things I did now going back a couple of years was I added Objective-C generics to the output of the Kotlin compiler, right? Like, that was my major contribution to the Kotlin proper thing. And, Kotlin, Objective-C, and Swift are different languages. So we were able to add at least some usable generics to the Objective-C, and they're usable in Swift, but like Objective-C has some sense of variance. Kotlin has a more sophisticated sense of variance. Swift does not. So you're able to cast around those problems if it's coming from Objective-C, but direct Swift you would not be able to. So you'd probably lose a lot of generics, or at least it'd be weird rules. So I don't know. It might improve performance some. I suspect it probably would, but like not at the degree that you would ever notice unless you were measuring like really crazy.
If you are crazy on measuring, you may notice.
You might. So I would say anybody that is like waiting for Swift interop before they use KMM, I think, not to judge, but it's like you're not going to get the things in the language that makes Swift, right? Kotlin is different, so it's never going to be perfect. Not that Objective-C's interface is perfect either, but I wouldn't wait for sure. Like, so I'm like, to me, it's not, other than it's like a checkbox item. People are like, is there Swift interop? And I could say yes, great, but it doesn't change our day-to-day coding at all.
Thanks. So. I think this is a great time to refer our audience to visit our roadmap page. And yes, you will find the ticket, the task, the U-track ticket with direct Swift interop there. But you will also notice that it's on pause now, because currently the whole focus of the Kotlin native team is on the new memory management approach, and maybe we'll have time to discuss this question also today, but maybe not. We'll see. It's a question we could arrange a dedicated webinar for that, but let's decide later.
I'm sure that will be one of my conference talks sometime later or next year.
Only after the blog post, please, Kevin. We agreed on, of course. As I said, let's move to the community questions, and let's pause a little bit our iOS discussion. And there is a good one. What is the best way to build internal libraries that can be reused for multiple projects? It's a relevant question for big teams and big organizations like SDKs. How to modularize properly? Is local Maven enough or not?
There's a lot in that question, and I'm not sure I understand all of it. To go from the, LIFO direction here, local Maven, just published to Maven local, I guess. I don't know that it's enough. I mean, I don't know how you would share it with anybody. We do a lot of that when you're developing locally, but then when it's time to like share the thing, so you need to publish somewhere. My world is kind of split between open source and not open source. So open source, we're doing just Maven Central now that Pinterest is, going away or whatever. I would say no, local Maven is not enough when you need to publish, because obviously you have to share it with people. We are doing a private thing now with an internal SDK team that is publishing to, I think, GitHub packages. So we'll see how that works out. But we're not publishing Caleb's. We're publishing, I guess, terminal things. So Xcode Framework or AARs. So I don't know if that would actually work. So I can't answer that question, unfortunately. But how do you modularize popular? That's a hard question too. I think that's just software development skills. I don't have anything specific to KMM that would be a different answer than how would you modularize in an absence of sharing code. Do you know what I mean? Once you've selected things that are going to work for KMM, I think then it is like a normal modularization thing. Now, and specifically KMM and iOS, if these modules need to be able to talk to each other in any way, you're going to have to package it as a single framework. And that gets much deeper in the rabbit hole of KMM world. So, yeah, I don't really have a specific answer that's more than like what you would do normally. I'm sure that when this call is over, I'll think of about 100 things, because we're actually doing this with multiple teams. This is turning out, I guess this is news for everyone at JetBrains too. It seems to be more than I would have guessed. Not that I would have guessed low, but a lot of teams are starting to publish at least trials of internal SDKs that are from KMM. Like we got one surprise this past week, because it was like they filed a bug, and I'm like, "Where's this code?" And they're like, "Oh, here's our SDK publishing." Oh, it's amazing. I have no idea what your bug is, but like it's amazing that you're publishing your library that way. So anyway, sorry, I don't have a better answer for that.
No problem. Another one, and I'm sure here's a good space for discussion. What do you think about combining modern Android and iOS SDK tools with KMM?
iOS SDK tools. I don't understand the question.
I initially thought that it's about UI tools, UI declarative tools. Maybe. Let's pretend this is that option. But if not, please, the author of the question, specify what tools you were thinking about.
So I mean, yeah, Brady from our team. Hey, Brady. This week we're working on CampKit Compose as a public example, and then if we get to it, we're going to do the Droidcon app Compose. In the Android world, Compose is stable sometime in the coming month, according to Google's projections. So I think not incorporating Compose, at least understanding how that would work. It's not like everybody's moving to Compose overnight, but you're going to need to be able to interrupt. The question is, does that change your architectural organization? And that's actually kind of what we're focused on now. But again, going back to John O'Reilly, Arcadie is doing a lot of stuff with Decompose. There's a lot of things going on in the ecosystem around how to attach Compose to Kotlin and KMM specifically. To me, it's more of an architectural question than it is a technical question, because technically they go together fine. Swift UI is a different question, and we tend to focus our attention on the Kotlin side of the world. So, and I'm trying to keep a pulse on the community, the iOS community, like how much are you using Swift UI? And the rollout hasn't been, let's say, entirely smooth. So we've been less aggressive at our team jumping into that research, where I'm not going to say why, but we've been experimenting with actually driving UI kit layouts with Compose on iOS, but don't get too excited. I don't know that that's going to really work.
We can't get too excited when we hear Compose and iOS in one sentence.
I know, but it's
be not excited.
It's not Compose. It's not Compose UI. It's not like a custom UI. It is purely doing layout. But it's because the JetBrains team, the web team, is doing like this. They were doing like this common widgets thing with Compose. So I was trying to adapt that to iOS as well. But it's mixed results. We'll see how that goes.
Okay. And well, the last question, Kevin, sorry, but I just can't let you go without that kind of discussion. So I think you're ready for it. Yeah. What's up with multithreading? Yes. Are there best practices? Especially taking into account that we all know that we are working on the new memory management approach. I think so. This is the bigger question. It's bigger than just practices how to write code and where to write code.
So what's up with multi-threading, I think, is let's try to condense that as much as we possibly can. At runtime, if your data is mutable, it has to be in a single thread, or it's frozen, immutable, and it can be shared across threads. That is the most condensed way I can explain what's up with multi-threading. And what you just mentioned, like the team is working on changing that model so that it is, and it's, well, to be clear, it's only on native that it does that. So it's confusing for people that are coming from the Android world where they can do whatever they want, and then now they can't. So that memory model will change. I don't know that we know exactly, like, is it going to be exactly like the JVM where you can do what you want, or are there going to be more rules? I don't know if that's been entirely resolved yet. But I would say I've been talking about this for the last few years, and I conceptually think it's not a bad thing because it forces you to think about the places where you could be doing something that is problematic. But in that weighed against people having to learn it and running into problems, and like once you get a really complicated object graph, you can freeze things unintentionally. So it's not necessarily good. But what's going on is we tend to focus more on explaining to people general patterns of usage now than just trying to explain everything in a theoretical ball, especially because it is going to change at some point and it's whatever. So I would say best practice is you should be intentional and aware of what parts of your architecture are going to remain immutable and which ones aren't. And I think that that's good recommendation in any context. Like you should be aware of what parts of your code might be going into a different thread, so you're not touching parts that aren't in that thread and doing weird things. I think the native model forces you to do that even more so. We tend to do view model layer stuff, not to get deep in the weeds of mobile, but view model layer stuff tends to be not frozen, intentionally mutable, and then everything else assume it's frozen and it's coming from the data, and you shouldn't, you should be transforming data, not modifying it anyway. So stuff coming from your database should be in, immutable data classes, things like that. I would say best practices, we use the multi-threaded coroutines branch. Most of the time, if you're just using that to go across threads, you don't have to worry about freezing anyway, because your data will get frozen where it needs to be. So it's not a lot to worry about. And if you're not coding like libraries specifically around concurrency, there's really nothing that's going to change in your code when the new model arrives. So it's not something to really worry about. Should you still go read some blog posts, perhaps by someone on this call, about how to do this stuff? Like, sure, because you're going to need to understand it. But I wouldn't say you need to do a deep dive. Like, perhaps not watch the talk at Kotlin Conf that I gave. But the feedback was like, there's too much in there. I'm like, okay, that's fair. But go to the hands-on tutorials on the KMM site. That's generally enough to get you started, and you don't need to worry about it too much. But yeah, like, I worked with the Coin team on their native implementation. That's going to have to change because it intentionally directly deals with concurrency and management. We have a library called Stately. I don't know what the purpose of Stately is once we don't have the same restrictions, because it's entirely around concurrency. So if you're not working on that kind of stuff, it's not a big deal. So.
Agree. It's a great time again to now mention our KMM documentation portal. And Kevin wrote a couple of articles about multithreading. And I think their level is quite good to you, not to get, I would say, tired for it, but to get the needed understanding, just to be confident that you understand what's going on. So please visit KMM documentation portal, and also there you will find a lot of articles. We also have an article with a set of frequently asked questions. They are much simpler than those we discussed today, and for that discussion, Kevin, thanks a lot. It was great.
Thanks for having me.
A lot of great advices, numerous mentions of cartridge unexpectedly.
Let's just put that out of your mind.
I'm not sure I can't, but I'll try to. And public promise, great discussion, and again, great answers. So thank you. And that was 10 questions you always wanted to ask about Kotlin Multiplatform Mobile. I feel that it was the first, but definitely not the last KMM webinar. So again, don't forget to subscribe to our channel, not to miss the new content. And see you later.
Okay.
Bye-bye.